Hello, welcome back to Cracking the Cryptic, and today we're looking at a puzzle by Exley, who's new as a constructor to the channel, I believe, and it's called Phistomefel 5, and there's a little line in the instructions when I called up the puzzle saying it's a Sudoku inspired by Phistomefel's ring, not to give any clues on how to solve this, of course. So we get a better, maybe a hint, although who knows. I'm looking forward to giving it a try. There's palindromes and region sum lines and German whispers and a good mix of the standard rules that we use quite a lot. Now, if you want more practice in those standard rules, there are various ways to go about getting it. You could get our apps, which feature classic Sudoku 2, not a variant, of course, the latest one, but also line Sudoku, domino Sudoku, etc. And you could also try the Worms, which are brilliant too, by the likes of Michael Lefkowitz and Phistomefel himself. And you could try our hunt on Patreon. So the December hunt is Wind in the Willows. Mole tries to get through 12 puzzles and open his advent calendar, so you can help him, and he'd definitely appreciate that. Do have a look at that if you're with us on Patreon. Join us on Patreon if you're not, and you can also watch all the connections and crossword videos there too. So those are great things. There's also a link to Sven's Sudoku pad under the video in the description field, but there the first link is to this puzzle, Phistomefel 5 by Exley, and I'm going to do the rules now. Normal Sudoku rules apply, so 1 to 9 in every row, column and 3 by 3 box. Then, along a green line, adjacent digits have a difference of at least 5. The grey lines are palindromes that read the same forwards as backwards, so that digit will be the same as that one. For instance, on the blue line, box borders divide it into segments with an equal sum, so those 3 will add up to that one, and the same as that one. We've got some Kropki dots, so on a black dot, one digit is double the other. On a white digit, there's a difference of 1, and on an X, the digits sum to 10. Those are the rules. That's all we need, apparently. Give it a try on that first link under the video. I'm going to start now. Let's get cracking. So, we've got... okay, before I tell you about a German whisper line, I'm going to tell you about a blue line with a 3-cell segment and a 1-cell segment. So the 3 cells in the same box have to be at least 1, 2 and 3. They add up, therefore, to at least 6. And that applies on both ends of this line. These digits are the same, and they are 6, 7, 8 or 9. Now I'm colouring them orange, not because they're the same, although they are, but because I want to distinguish between high digits and low digits, and that's for the purposes of colouring the green line. So, on a German whisper line, we have no 5s, because there's no digit a 5 can sit next to on a green line. We have therefore got to alternate between digits higher than 5 and digits lower than 5, much like this. Oops. Those will all be low, and these will all be high. And 6s and 4s are quite difficult to place on this line because they can't go in cells where their 2 neighbours would see each other. They're monogamous. They only have one possible neighbour. And if you were to try and put a 4 there, you'd have to put 9s in both those cells. And that's not allowed. Therefore, all of these blue cells are 1, 2 or 3. All of the orange cells are 7, 8 or 9, apart from the corners, where you could fit a 6 in with 1s in the boxes either side. So, let's go to this black dot now. 7 and 9 cannot sit on a black dot, because they can't be half or double another Sudoku number. So that is 6 or 8. We get 3 or 4 on the other side of the black dot. I could colour that low. This is also high, because it's 6 or 7. I wasn't planning to really extend the high-low colouring outside the Phistomefel ring, but this has been quite useful because we've found all 4 orange digits in column 7. And that means 5 and a low digit are up here somewhere. Also, yes, I did tell you that 5 can't be on the green line. I didn't tell you that 5 can't appear on an X, but that's also true, because any one of these X's with a 5 on would have to be a 5-5 pair sitting next to each other in the same row or column. Not allowed. So in row 3, where does the 5 go? It must go in one of those cells. In column 3, it must go in one of these cells. And in row 7, must be one of those cells. And the 5s are sort of acting like vanes on a windmill here. They're rotating around the grid. Do we know more on the palindrome? Yes, we do. This can't be a 5 because that would, the second position on the palindrome would put a 5 here, which is impossible because 5 in this box is in one of those cells. So that's not a 5, that is, and that works here as well. We can't put a 5 in that cell because that would put a 5 here and we'd have 2 in the box. So that's not a 5, and that is. So we've got a couple of 5s in the grid. There's also going to be a 5 in one of those cells. Oh, there's going to be a 5 on the palindrome. Now that's a bit confusing. You may be asking, how can there be only one instance of a digit on the palindrome? Because you can see that none of these digits can be a 5. So if we're going to put a 5 in one of these 3 cells, as we have to for the row, it's not going to have another 5 on the palindrome. Now there is obviously one instance where that 5 can be, and that's in the central cell of the palindrome, which is right here. So this digit is 4 or 6, and this is lovely actually. That has to be the same as this by palindrome rules. So we've got 4 or 6 here, 3 or 4 here. Clearly the commonality is a 4. And now we can start with this X, we get a 6. With the black dot, we get an 8. With the black dot here, not necessarily 8. This could also be 2. That 8, well, and that 6. That the 8 sees, oops, all of these orange cells that can't be 8. The 6 sees that one. And now we know that this line has an n, a segment sum, of 7 or 9. So that can't be 6 either down here. So this trio is either summing to 7 or 9. Okay, maybe we'll come back to that. Now, here's a good question. Where does 6 go in this row? It can't go here in the same box as another 6. And all of these are pencil marked without it. So it's got to go over here on the X with 4. And this is going to be a low digit, 1, 2, or 3, according to this 7, 9 pair, 8, 5 in the row, and 4, 6 over there. So we can replicate that on the palindrome. And where does 4 go in this column? It doesn't go there. So it must go on the X. So that's a 4, 6 pair. We take 6 out of this corner cell. That's really helpful too. Let's just look at this. This is again from the 1, 2, 3 triple. And those again replicated on the palindrome. So those are both from 1, 2, 3. Now, 4 and 6 can't go in those cells. So in this row, that's a 4, 6 pair. And just as 5 was windmilling around the grid, I think 4, 6 are doing the same on the sort of other possible windmill vanes. In fact, all the given X's are 4, 6 pairs, and that's been proven. Now, that's a great start. And we were racing along, 6 minutes in. But what do we do next? Where is the middle of this palindrome? I think it's there. So these 2 digits are exact same. This black dot is, it's on the palindrome, it's 2, 3, no it's not 3, it's 2, it's 1, 2, 4 or 6. Sorry, 2 can be next to 1 or 4, 1 can only be next to 2, 3 can only be next to 6. And that is replicated here on the palindrome. That's not actually that helpful. 8, 4, 6, 7, 9, one of these. Yeah, so this digit on the palindrome is 1, 2, 3, or 5. That's here. Again, I'm not really convinced of the value of putting in those candidates. 6 is in one of these cells. I'm sort of grasping around a bit to know what to do. I know I could try and use the Phistomefel ring and explain the whole theory to you. I'm not sure it's going to matter all that much. I think things are being are going to get forced into the Phistomefel ring by the natural geometry of the puzzle without me worrying too much about exactly what is in it and what isn't. So I'm only going to explain the Phistomefel ring and its theory as a last minute or as a sort of desperation if I need to. Right, these three add to 7 or 9. Now, if they add to 7, they are 1, 2, 4. But look at these two digits. Let's colour them yellow. Yeah, let's colour them yellow because on this sequence of 4 dots, which I've now made look like a Battenberg cake, randomly, these two have to be the same parity. I do mean parity this time, not polarity. So if that's odd, these are both even. And if that's even, these are both odd. So these two together add up to an even number because they're the same parity. And yet we're coming to an odd total of n. So this must be an odd number. Now I'm not going to make it orange because that would confuse me with orange being high in the Phistomefel ring. Actually, I am vaguely thinking about removing all the orange and blue now. Yeah, let's do it. Let's remove orange and blue. And, ooh, it looks very empty grid suddenly. But this is 1, 3 or 5. I know it can't be 7 because this line would add up to at least 10. These two are 2 apart. Oh, so that's interesting. Right. If this is a 7 sum, these are 1, 2, 4. I think that then has to be the only odd digit, which is 1. You'd put 2 and 4 here. You'd get a 3 here and a 5 here. I think that would work. That's possible. However, it's a bit more likely, because there are more possibilities, that this is a 9. However, 1, 2, 6 can be ruled out immediately because the two digits that are the same parity, 2 and 6, are not 2 apart. Whatever digit you put there would be wrong on one of the white dots. So 1, 2, 6 is not possible. 1, 3, 5 is definitely possible. These would be odd. 2, 3, 4. 2, 3, 4 is not possible. These two have to be the same parity. They'd be 2 and 4. So you'd be putting a 3 there, but also in between the 2 and the 4. Right. So this is either 1, 3, 5 if we're making a 7, 9 pair, or it's 1, 2, 4. Sorry, it's either 1, 3, 5 if we're making 9 here, or it's 1, 2, 4 if we're making 7 here. And this digit coming between, oh no, it could be coming between 1, 3 or 3, 5. It is 2, 3 or 4. That's not really as helpful as I was hoping to get here. These are from 1, 2, 3, 4, 5, and they are the same parity as each other. This cannot be a 2 because that would be a 4 being the same parity as you go around here and would clash with that. So that's not a 2. And that means 1 is not on these in these yellow cells. Yes, it does. The fact that that can't be a 2 is enough to do that. And now this must be a 1 because this is either 1, 3, 5 or 1, 2, 4. We get a 1. Now there's a bunch of digits that can't have 1 in. And that's those ones. This is not able to be a 3 because on one side of it you're going to get a 7. And 3 can't sit next to 7. So that's a 2. We're in business now. This is a 3. That must be surrounded by 8 and 9. This digit is lower. This digit is 7 because of that 8, 9 pair. And now we know what's going on this line. It's actually the surprising lower total. This is a 2, 4 pair. This is 3. We can't put 1 here, so we're going to put 5 here. That sorts out the 4 and 2, and our Battenberg cake is complete. If you don't have Battenberg cake in your country, you don't know what I'm talking about with that yellow-pink arrangement. And I pity you. Pity you. Now, this is a 9 because we've had the 7. Oh, look, that makes this an 8. That's on the palindrome. We get 8 there. I've probably got to sort that out. I'll do it in a moment. I get 9 here. This 7 can't sit next to a 3, so that's great. We get 2 there. We can put 4 on the palindrome. That goes here. That sorts out the 6, 4 in this X, and that's also on the palindrome. So 6 is on the end of the line, and 4 isn't. This digit sees 2 and 3 now, so that's 1 or 5. This digit sees a 2. Is this one not resolved? No. This is a 9. That is resolved. 7 can't sit next to 3. Oh, those aren't fixed. This one is, because it sees a 2. So is that one. 3 and 8 go in there. This is now not 3 on the end of the palindrome, so I can do that on the end of the palindrome there. This is also not 3. So we've got a 1, 2 pair on the end of the palindrome. This digit is there. No, it's there. And here it can't be 1, 2, 4, 5, 6, 8. Here it can't be 3, 9. It is 7. This is a 3, 9 pair. This is going brilliantly. 8 there. This is a 3, 9 pair. I don't know what that is. These are from 1, 2, and 6. What about this palindrome cell that has not been looked at? 4, 7, 6, 8, 5 are all impossible, and 3. So this one is 1, 2, or 9. That's not all that helpful either, but I'm going to mark it. Okay, 8. I can place 8 in the central box because it can't be in those cells. Oh, look, it's in the center of the palindrome. And indeed, the whole center of the palindrome goes 8, 8, 8. Rather surprisingly. Now, that can't be 9, that can't be 9, so this is 9. These are a 6, 7 pair that is probably done somehow. I don't quite see how. That's from 1, 3, 5 in its column. I really don't want to suddenly have to use the Phistomefel ring. This digit, oh no, I thought it was going to be known. It's not. Okay, let's do this stuff. We've got, that's not a 2. We've got 1, 3, and 5 as candidates here. 8 is in one of those cells. I can't see the point in marking that. Ah, I can find 4 in this box. It's there. 2, 9, 4. So 5 is not here. 3 and 8. 8 is in one of these cells. I think I was going to mark that earlier and just didn't. 9's in one of those two. Why is this getting tricky now? This has surprised me a bit. I'm tempted to colour these 1s and 2s. Yeah, I'm going to do that. Let's make that one red and this one yellow. That red sees this cell, which is yellow. On the palindrome, we know that red's at the end and yellow isn't. In this column, that becomes red. So these two are now different. There's a red somewhere up here. There's a red in one of these two cells. Ah, that is red. You see, that's useful to know. Because of this red and this red. Oh no, hang on, 2 could be red. That could be wrong. I have to remember that we've marked some of these reds and yellows like we've put in the digits. Oh, bother, yeah, I nearly made a mistake there. I don't know if it would have been costly, but it would have earned a reputation of making mistakes. Right, this is a naked single. 6, 4, 5, 7 in the row, in the column, 9, 2, 3, 8 in the row. That digit is a 1. This digit is a 5. That's on the palindrome. This might get me going again. That 1 makes this a 3. This completes the column because I get a 1 there. This digit on the palindrome is not a 1 now. 2, 9, 3, 4, 1, 5, 8. That 9 is looking at the digit on the palindrome. It's making it a 2. That is looking at the red square digit, making it a 1. That means the yellow cell is a 2. And we are flying. This is a 6-1 pair now. That's not 5, so 5's here. Oh, sorry, it's still in the mode. That has to be an 8 because it sees 6 and 7 in its column. Now we've got a 6-7 pair in this column. And that's 6 or 7, but it's sitting above a 6, so it's 7. And that unwinds the 6s and 7s in boxes 6 and 5. This digit seems to be 3 or 6. This one, to complete the column, is a 7. Then I can put another 7 in the grid, which I think is the last 7 in the grid. That 4 has seen 6 there, and 3 here, and 1 here. And we've got 5, 6, 9 to place. 6 I can do, but not 5, 9. Then I can do the 1, 6 down here. 9, 6, 4, 7. We need a 1 in box 1, and it's there. So then I can fill in 3, 5. Then I can complete 3, 9. This must be a 6 in the column and a 9 in the box. 2 and 8 up the top. Now we're getting very close. That's 9 and 5. This row needs a 9. That's going to give me a 3 in the corner. That's 3 in the corner. That's 3 in the spotlight, losing its religion. And I think 8 here completes the puzzle. And thank you very much, Exley. It's a fun one. Congratulations on completing my very first puzzle. Hope you enjoyed your stay. I did. I hope you enjoyed trying it, because that was good fun. Thank you for watching us on the channel. As always, a pleasure to have you with us. Hope to see you soon. Bye for now.